All right, welcome to Unit 9, Homework 0. I know it's weird, Homework 0, but this is just a quick introductory lesson on how to classify three-dimensional figures. So in the first half of the unit, you did area and perimeter of two-dimensional figures. All three-dimensional figures are made up of two-dimensional figures. So you probably have a good idea on some of the names, but some of them might be a little bit different than you're used to. So for everything we're going to name, there's going to be two parts. We're going to name it based on how many bases it has, and then we're going to name it based on the shape of the base. So let's take a look at some of them. Let me go ahead and share my screen. We're going to be looking at the next blank page in your notes. It's called Classifying 3D Figures. So if you could turn to that page, and just a second, you'll see what it looks like. Okay, it looks like this. Okay. If we were in class, I'd be able to show you like physical objects, but we aren't in class, so I'm not able to do that. I apologize. But lots of people teach this without having the 3D objects, so we'll be okay. If you want to find some in your house or something that you could use to look at, that could be helpful too. Okay, so basically, we've got 5 different names, and you don't have to memorize any of these. And if today seems kind of confusing, don't worry. We're going to definitely go over these throughout the whole unit, so we'll keep coming back to this stuff. So it doesn't all have to click exactly today. It is just an intro, so we're all speaking the same language as we go into the second half of this packet. All right, so we've got prisms. Prisms are solids that have two bases that match each other. So they're congruent and they're parallel. One's on the top, one's on the bottom. So like a book, right? A book is a prism because here's the front of the book, here's the back of the book, and the top and the bottom match. They're exactly the same size. So if you look at this figure here, the top of this prism is a triangle, and directly below it is another triangle. And we would call this a prism because it has matching bases, and we'd call it a triangular prism because the bases are triangles. Okay, cylinders are also prisms, but they're special kinds of prisms because they don't have sides. It's all one, it's just round, right? So like my drink cup is a cylinder, your water bottle is a cylinder, okay? The bases match, there's one at the top, one at the bottom, and they're circles, okay? Does anyone know if you were to cut a cylinder down the side and unfold it, what shape the sides would be? Like, have you ever done that with a soup can where you cut off like the label? Yeah, it's a rectangle. Kind of interesting. Okay, so those are prisms. Pyramids are pretty much the same thing, but they don't have a matching top and a bottom. They just have a point at the top. So this has one base, and the sides come up to make a point. So like the Luxor in Vegas is a pyramid. This is called a pyramid because it has one base, and it's called a triangular pyramid because the base is a triangle. All right. A cone is also a pyramid, but again, it's a special one because the base is a circle. So you could call it a circular pyramid, and you could call a cylinder a circular prism, but we just gave special names for those, just kind of like we have circumference instead of perimeter. Yeah, so as a circular base, and there's a point at the top. Okay, the last one is a sphere, and a sphere isn't a prism or a cylinder, it's just a round blob. That's the mathematical term. No, actually, it's like a basketball or a bouncy ball or any sort of perfectly round ball, not a football. It says that the point in the middle is equidistant to all points on the sphere. So if we took all the points in all the directions and connected them, we just have a round 3D object. Okay, so what we're going to do is we're going to name things based on their bases. And the way we do that is depending on how many sides it has. So we got to kind of go back to, I don't know, 4th, 5th grade when you guys learn what shapes were called based on their number of sides. So what's a 4-sided figure called? A quadrilateral. And there's lots of quadrilaterals. We could have a rectangle, we could have a square, we could have a rhombus, we could have a trapezoid. There's lots of different names. So I'm not going to put that one down, and we don't actually say a quadrilateral prism. We name it based on, if it was a rectangle, we'd say a rectangular prism. If it was a trapezoid, we'd say trapezoidal prism. If it was a rhombus, I don't know what we'd call that. That'd be weird. A rhombozoidal prism, maybe that's a thing. Yeah, but what's a 5-sided figure called? Ah, a pentagon. Nice. So let's put that in our notes. Remember, you don't have to remember any of these things, but you want to have it to look back on in case you forget. Okay, what about a six-sided figure? Did you say hexagon? Nice job. Okay, I feel like I'm doing a kids show, like where they ask the little kids a question on the camera and they give you time to think. And then you say, oh, good job. Seven's kind of a tricky one. Does anyone remember what seven is? Heptagon. Yeah. So we've got heptagon. Okay, so gon just means sides. It's a seven-sided thing. Okay, and then eight, everyone usually knows eight. So the shape of our stop sign, it's an octagon. OCT, why am I drawing a blank? AGON. Yeah. I wanted to put an O there, another O there for a minute. That was weird. Okay, so we're going to use those. I stopped at 8 because those are all the ones we need. And maybe later on in math, you'll use bigger numbers, but for now, we just need those. Okay, so the other thing that if you notice it's going to ask us to do is we're going to name them, but we're also going to figure out it's how many faces it has, how many edges it has, and how many vertices it has. So a face is like this book, right? This is a face of the book. This little part of the spine is also a face. This other part of the spine is a face. This is a face. This is a face. The back's a face. So there's all these faces. Faces are like flat plane shapes. Plane as in Plane, which is a geometry term to say it's a flat thing. So off to the side, I'm going to put what a face can look like. Okay, and it's not a smiley face. So a face is usually a triangle. It is usually like a rectangle or it's a circle, or I'm going to put dot, dot, dot. Could be a pentagon. It could be a hexagon. You get the idea. Okay, edges are where two faces come together. So on this book, an edge would be right here where the bottom cover meets the spine. Okay, this would be an edge right here. So what we're looking for edges are straight lines. And sometimes we're looking for the dotted lines too. So it can be a line like this or a line like this. And those dashed lines are just ways to draw three-dimensional shapes so we can see the dimensions. Okay, the last thing is a vertice. I'm going to move up just a little bit here. And a vertice is where the ends of two edges come together and make a point. Okay, so in number 1, that little orange dot, all of these little dots right here are vertices because the edges met and made that a point. So for vertice, I'm just going to show 2 lines coming together and then an arrow. So we're just going to count all the points. Okay, so remember, when we classify a solid, we give it 2 names. We name it based on how many bases it has. 2 bases, it's a prism. 1 base, it's a pyramid. And then we name it based on the shape of the base. All right, so let's look at number 1. Okay, we look at number 1 and I see that there's a top and a bottom that match, so I know it's a prism. Now I have to ask myself, what's the shape of the base? You can look at this in a bunch of different ways. You could say that this is the bottom, this like the long thin rectangle, and that's the top. And some people see it that way, and that's fine. You could say that this small rectangle and this other small rectangle are the top, the top and the bottom. Okay. I think the way most of you probably see it is to say that this big thing on the bottom and this one on the top are the bases. Okay, and it doesn't really matter. But in all the cases, the opposite sides are all rectangles. So it has 2 bases, so it's a prism, and they're all rectangles, so it's a rectangular prism. Those are the 2 parts of the name. So let's write that. Rectangular prism. Okay, now we're going to count up the faces. So again, the faces are those flat pieces, and these are all rectangles. So I've got 2 on the top, or 1 on the top, 1 on the bottom. So that's 2. 1 on the right, 1 on the left. So that's 2 more. And then I've got these other outer edges. So I've got a total of 6 faces. And it's kind of hard to show you how I found them on the figure, but hopefully you're able to see them. And again, we'll keep working on it as we go. Okay, edges. So to find edges, I could just trace them all. So there's an edge and there's an edge. I've got 2. Then I've got 3, 4. Then I've got 5, 6, 7, 8. And is there any more? Oh, yeah, I didn't do the corners. So then I got 9, 10, 11, 12. So there are 12 edges to this figure. All right. Now, lastly, let's count up the vertices. So there are, let me just erase all those little green things. Let's get a different color here. There are 1, 2, 3, 4 on the top. And guess what? There's also 4 on the bottom. So there are 8 vertices. Okay, so we had 6 edges, 6 bases, 12 edges, 8 vertices. All right, cool. Let's look at number 2. Number 2 does not have a matching top and a bottom, so it's a prism. So we start there. Then we ask ourselves, what's the shape of the base? So if we look here, the shape of the base has 1, 2, 3, 4, 5, 6 sides. And if you look back up at our list at the top, a 6-sided figure is a hexagon. So this is called a hexagonal pyramid. I feel like the pyramids are a little bit easier to see stuff because they're not on top of each other. So we're only going to do one pyramid example, and we'll do a couple more prisms. Yeah. Okay, so faces. There are, if we look at the faces, there's the one on the bottom that I just outlined. So that's 1. Then we've got 2. There's 1 here in the back left. That's 3. Straight back is 4. Back right is 5. Front right is 6, and the very front is 7. And I know that's kind of hard to see, but an easier way to think about it is to think if the base has 6 sides, there's a face coming off of each base. There's 6 faces around the sides, and then the one on the bottom. So a pyramid always has one more face than how many sides the base has. And if that doesn't make sense, again, don't worry about it. We're going to keep talking about it. Okay, we got edges. So let's look at our edges. We've got, let's change colors here. I like to do that. We've got 1, 2, 3, 4, 5, 6. We have 6 edges coming off of just the top down. And then we also have, going around the bottom, 6 more edges because that's how many sides there are. So we have 12 edges. Okay, vertices. Let's do vertices here. Okay, vertices, we got 1 at the top, and then we've got 1 at every corner of the base. So the base has 6 sides, so there's 6 of them, and then 1 at the top, so 7. You're gonna start to notice some patterns. All the prisms have a pattern to them. All the pyramids have a pattern to them. So I encourage you to kind of think about what those patterns are, and we can talk about it next class. Okay, we're gonna do 2 more. And again, we're gonna do prisms, okay? So let's look at number 4. Number 4 has a matching top and a matching bottom. So this right here is the top or the bottom, however you wanna look at it. And the one that matches it is back here, okay? So it's kind of hard to see it, but those are pentagons. And it has a matching, so it's a prism. So this is a pentagonal prism. Okay. All right. Now we got to figure out how many faces it has. So a pentagon has, there are 5 faces coming off of the sides. There's 5 all the way around, and then 1 at the top, 1 at the bottom. So there are 7 faces. Okay, edges. There are, if I draw them, 1, 2, 3, 4, 5. So there's 5 around the sides. There are 5 around the top. And if there's 5 around the top, there's got to be 5 around the bottom. So 5 on the sides, 5 on the top, 5 on the bottom. 5 times 3 is 15 edges. Okay, and I hope I'm not going too fast. If I am, feel free to rewatch it. Yeah. Okay, last thing, vertices. Okay, so the top base has a few vertices. The top base has 1, 2, 3, 4, 5 vertices. And the bottom base has 5 vertices. So 5 plus 5 is 10. Okay, are you noticing the pattern yet? There's a pattern. Okay, last one, number 8. Number 8 is a prism again, because there's a matching top and a matching bottom. Remember I said a four-sided figure can have lots of names. What shape is this base right here? It's not a rectangle. It's not a square. It's not a rhombus. It's not a parallelogram. It's a trapezoid. So bases match, it's a prism. The base shape is a trapezoid, so it's a trapezoidal prism. All right. I think that's probably the weirdest one that you'll do. And if you call it a trapezoidagon or something like that, don't worry about that. As long as you have the word trapezoid in your name, you're fine. Because some of these are weird. It's like, why does it end in an AL and why does it end in a, I guess they all end in AL. Anyway, okay, so faces. There are a face on the top, a face on the bottom, so 2, and there are 4 faces around the outside, so there are 6 faces total. Okay, let's look at some edges. There are, let's get a new color here. There are 1, 2, 3, 4. 4 on the sides. 1, 2, 3, 4 on the bottom. And if there's, that's not a very good edge. If there are 4 on the bottom, 4 on the top, and 4 on the sides, that gives us a total of 12 edges. Okay, last thing, vertices. All right, so vertices, remember, are where the 2 lines come together to make a corner. Trying to get rid of that there. And our vertices are, we got 1 at the top. I'm looking at the back base here. So I got 4 on the back base, and then I've got 4 on the front base. So there's 8. Okay, so your homework before next class, because we're going to use all these terms in the next class, is to finish these problems. So if you look back at the sheet, notice we didn't do number 3. We didn't do number 5 or 6. We didn't do 7 or 9. And then on the next page, we didn't do 10, 11, or 12. So your homework is to do all of those, okay?